Good day, everybody, and you're all very welcome to this Saturday's CNPS alternative session. My name is Ian Cowan. I'm from Dublin, Ireland, and I'm hosting these sessions at present. We hold them every fortnight, and we endeavour to go into some detail on some technical aspects of fundamental physics. Usually from a dissident point of view, but that's not required. It could be an orthodox point of view as well. The alternative, or the alternate, mix up the words alternate and alternative, but alternate Saturdays are actually, when they're held, they're of a more general nature, but they're basically on fundamental questions in physics as well. Now, today we had scheduled a gentleman further east than I am, from Kolkata in West Bengal in India, Dr. Abhishek Chakravartty. And he had quite a general title: Necessary Truth, a truth which always has to be a truth, may not appear to be a truth in some cases. And the title was Situation Regarding Change in Necessary Truth. So I think his intention was, I'll explain the past tense in a moment. His intention was to indicate that some things which are essentially true, they're like sort of analytic propositions in Kantian terms, might not always be so. But he has expressed some interesting concepts in regard to the ether, and also in regard to things like multiverses. And I think his intention was to bring ideas like that in. Now, the bad news is that he's contacted me a little while ago to say that his computer broke down. It seems to be just Murphy's Law. And he's endeavored to get in via smartphone, but the smartphone browser won't allow him to use his audio or video. So I suggested he try another browser, which he did. He said that won't allow him in either. Now, I actually have some indication here on the system that he's trying to get in, but his devices are not connected. So, yeah, okay, Eric, thank you. So we're going to have to ad lib a bit, because Abhishek may be able to put some comments in the chat, which we can maybe address, some questions or some points. I've asked him to send me a paper, but I don't think he has a one integrated paper. He has a lot of chat all over the place, which a lot of which I do have, but it would take me a while to retrieve it from my email. So I have some very kind offers from some of our members. I have an offer from James Keane, to show a short video, maybe 15 minutes or so, on the aspects of discrete space versus continuous space. And we could maybe have a brief discussion on that. I have an offer from Eric Reiter here. He has a video on his experiments, about 15 minutes as well, which actually would be useful because we had a talk from Eric some weeks ago. And Nick here, first of all, has his own website, which actually we were using before we migrated to StreamYard, rather, for these alternative sessions, and we may be able to do that. So I hope we didn't want to disappoint you. I know we haven't been talking to you for 2 weeks, so we said we'd have something today, come hail, rain, or shine. So I just want to see if there are any comments in, because if anybody has any comments, that's fine as well. So I think maybe we might start with this video of Jim's, which is on his Binary Mechanics Lab BitChute website. So let's see, can I bring that up? I'll have to, I have the address there, but I'll have to go to that, yes. Let me see. I have to share no, I have to share the screen. Okay. Now, I'll just while I have it up, there are a number of videos there, Jim. is it the first one, full quantization versus partial quantization? I just bring Jim up for the moment. Let me see now, because I just want to get this right. Sorry for all this messing around. So Jim, when I went to that website, there were a few. The top left one. Let me, just while I have you there, let me check it. Top left one. Is it one with like a sow and piglets, full quantization?
Yes, that's it.
Oh, okay. Now I'll bring you down.
It contains some material that I presented with the reviews of Jackson and Cornier.
Well, that's excellent, because it's a follow-on then from earlier work. And the spiel says conventional physics is based on partial quantization, continuous space and time. In full quantization, space, time, and energy are quantized. The consequences or advantages and disadvantages of each approach are presented.
And you can show it completely full screen, since nobody needs to talk during the video.
That's true, but I think I have to share my screen first, actually, even though I'm the administrator.
You share your screen and then take both of us down.
Okay. Well, if I just go in just to start the thing.
Same thing with Eric's video, which I look forward to seeing.
Okay. Hold on a minute. I wanted to stop it. Okay. Let me go back. So let me go down. So what I'll do is I'll take you down, Jim. Okay. Now, I have to share my screen, but I don't want to upset my own audio. Probably video file, is it? Or maybe share screen. Best thing. Yeah, okay. Share. Now I'm just going to check with you, Jim, because you're the man who constructed this, to make sure. Can you see it now?
Yeah, and be sure to maximize the screen when the video starts playing.
Yeah, I'll take
both of us down. That presumably the share screen will fill the entire StreamYard screen.
Okay, and I'll not bring you up again during this, but if it looks terrible, just wave to me and I'll bring you up, because we won't. Neither of us will have audio.
Hello, let's compare partial quantization with full quantization. Partial quantization uses the mother assumption of the theory that space and time are continuous. I recently presented a seminar to physicists, and somebody asked, where can I find this theory in physics textbooks? The answer is everywhere. It's the use of real number algebra and calculus in classical physics, special and general relativity, quantum mechanics, and the Standard Model, which define the partial quantization era, an attempt to model all points in space and time. Indeed, this theory is presented as fact in conventional physics textbooks. It is the mother assumption of its piglets and leads to their problems or limitations. Some of these limitations might be viewed as side effects or adverse reactions of the conventional physics assumption of continuous space and time. One is contradictions, such as ignored observations and experiments. For example, scattering data showing a non spherical proton shape is ignored as investigators continue to model and believe in a spherical proton. In addition, data analysis at Binary Mechanics Lab has debunked general relativity by showing the effect of object surface temperature in gravity effects using lunar laser ranging data and GRACE satellite data. Then we have dualities. The wave particle duality arises from inability to fully explain both sets of experiments, those appearing to show wave-like behavior and those said to show particle behavior. Another side effect of continuous space-time theory is paradoxes, including the twin paradox in special relativity and Schrodinger's cat in quantum mechanics. If there is not enough to worry about, then there is the magic side effect, namely the illusion that drawing a line illustrating position change in Newtonian mechanics actually explain how things move. Then we have miracles or impossible things, such as an infinite number of infinitely small sensors and supercomputers at every point in space, required to determine the value of various fields postulated by theoretical physicists. Another miracle are the infinite number of infinitely small inertial motion guidance devices required by general relativity. And physics classes usually require suspension of disbelief, as if you were watching a movie. As a result, many questions are not allowed. Further, the quantum mechanic wave function collapse issue can introduce the egocentric idea that the math works only when we are not watching, making measurements. Let's look at a simple table of issues in the theory that space and time are continuous. For the velocity variable, we have both a lower and upper limit in measured vacuum light speed c. Two more secondary constants are listed, the elementary charge and Planck's action constant h, where lower and upper limits correspond to measurement error values. The inverse R squared laws for gravitational, electric, and other fields give finite values for distance R greater than 0, but infinite results at R equals 0, a clear indication that partial quantization is flawed theory. On the other hand, for important variables like pressure, temperature, energy, mass, and energy density, 0 lower limits are recognized. But flawed theory allows infinite upper limits. Why is velocity the only variable with a real lower and upper limit range? Why no range for elementary charge E and action H? What is the rationale for the assumption that measured variables may have infinite upper limits? What does the supposed infinite upper limit on most variables imply regarding the quality of theories, or indeed the lack of useful theory? It is almost as if Satan said the values of C, E, and H are fundamental constants, not unexplained observation. The so-called Planck limits for length, time, and mass are based on three secondary constants, G, H, and C. Prior to binary mechanics, H and C were unexplained observations. The table shows the primary constants of binary mechanics, which are the basis for H and C. In summary, the Planck limits are a sort of magical mystery tour, credit to the Beatles, because they are merely combinations of unexplained observations, and there is no consistency. Many say that the laws of physics may not apply below the Planck length, but electrons, protons, and neutrons all are recognized particles, even though their mass is much less than the Planck mass. Go figure. Physics aims to explain how things work, but for decades, the microscopic mechanism of how things work has been hidden in plain sight. For motion in Newton's laws, drawing a line or a vector arrow from position r equals 0 to r equals 1 hides ignorance of how an object moves. In physics research, description of motion is only the first step. The end goal is knowing how things move. Luckily, the time development laws of binary mechanics provide a whole new level of detail about motion mechanisms. Next, consider particle interactions as shown in Feynman diagrams. Each vertex where lines meet hides the real physics at those crucial points. In contrast, binary mechanics presents the microscopic detail of what actually happens at these vertex points. Moreover, all possible particle interactions can be deduced from this analysis. Quantum chromodynamics, or QCD, attempts to model the proton as a set of interacting quarks and gluons. Computations are difficult, so a volume containing a 3D lattice of points is used. These simulations are known as lattice chromodynamics. This idea is illustrated in 2 dimensions in the figure, hiding in plain sight, so to speak, what is now known as primary length constant L in binary mechanics, and that space itself appears to have a lattice structure. Finally, the so-called fundamental constants, such as C, E, H, and alpha, are measured values with the status of unexplained observations. These values contain redundant information as shown by well-known expressions in physics texts. For example, with vacuum permittivity normalized, one may write alpha equals E squared over 2hc. This equation states that these so-called constant values are not independent, not fundamental, and indeed could not be fundamental. Think about that. Binary mechanics has successfully documented that these secondary constants, based on 3 primary constants, L, T, and M, perhaps ironically, map directly to the base units of measurement used in physics. We have talked about some of the consequences of the theory that space and time are continuous. I called them adverse reactions, sort of comically, if you will, of partial quantization, as seen in this Sherlock Holmes meme. The injections worked, Watson, he says. Now this student will not question the theory that space and time are continuous. Now let's look at some consequences of full quantization. First, minimum length L, area and volume. An elementary volume, L cubed, can contain only 0 or 1 things or units of stuff. If there could be more than one thing, their position would in effect partition and contradict the idea of an elementary volume. In sum, space is a medium with structure. Second, let M, energy in kilograms, represent a thing. Binary mechanics says an elementary volume called a bit locus may contain something called a 1 state or nothing called a 0 state, but does not tell us what a thing is. Abstract thinking required. Finally, the third thing, if something M moves from one elementary volume to an adjacent one where the displacement equals L, its velocity is finite. This position change occurs in 1 unit of time. Thus, velocity can only be 0 or L divided by t, called bit velocity. In summary, full quantization defines primary constants for the units of measurement MLNT, used in physics. There is one and only one set of values for the three primary constants, ML and T, which is consistent with the measured values for, as shown in the red boxes to the left, electron rest mass, vacuum light speed c, Planck's constant h, elementary charge E, and intrinsic electron magnetic moment. This is an amazing, even stunning result. Dad, why can't physicists explain how things work? We believe that space and time are continuous, son. I might add a key point to this comic meme. Namely, without full quantization, not only is major league progress in physics limited, in addition, such breakthrough progress is simply not possible. Whether or not I'm correct on this key point, a very important consequence of full quantization is the absence of adverse side effects. In binary mechanics, there are no known contradictions, dualities, paradoxes, uncertainties, magic miracles, and so forth. Instead, we may cite many benefits of full complete quantum mechanics. Binary mechanics has been the clear winner in the major events or competition in what we might call the physics Olympics. First, we have the century-long physics grand championship race, which we won with first ever derivation of basic constants from first principles. Next, we have the best system state representation of position and momentum simultaneously in the bit function. So the bit function defeats the quantum mechanic wave function 2-to-1. And we have the best time development laws, which are the laws of how the system state develops or changes over time, how things move, in other words. The bit operations defeat both quantum electrodynamics and quantum chromodynamics. And then in the competition for the best methodological advance in particle physics, we have bit function analysis. Most parameters quantized. In that competition, space-time energy quantization has won the day. And finally, the best physical force mathematical definitions. We've talked about the weak force debacle has been exposed and how using particle interactions or assumed particle interactions to define forces lacks scientific merit. I hope you've enjoyed today's little discussion. Thank you very much for your time.
Now, I've stopped sharing and come back to the discussion. So for my part, that was a most interesting summary of views, which actually Jim has adumbrated on previous occasions, but actually he's gone a bit further. And, it's a succinct plea, I suppose, for moving away from the conventional physics. This is as I see it, where you have things like dualities and you have paradoxes and you have magic and miracles, as he talks about it. And then you have strange things where only a velocity has limits and so on. So I'm just going to see, are there comments first? Because, let me just see. I hope, by the way, it was quite full. Let me see what the comments are. Right, okay. They're just positive, cool, and an emoji. So nothing more specific in the private chat. So is there anybody in the green room who would like to add to any of the comments that I've made or question Jim on some of the aspects? It seems quite remarkable that something which would get rid of a lot of these problems and paradoxes. Yeah, Nick, I'll bring it up in a second. Thank you for that. Has the ability to predict these fundamental constants to bring them out of the wash, so to speak, rather than have them derived or have them accidentally required. So anyway, Nick Percival has signaled that he has something to say. So I've added you to the stream, Nick, and
I am wowed by that presentation. That's critical thinking at the best, really. I can't say that every single detail is correct because I don't know enough to say that, but it really is. It takes a lot to take a totally different view than the currently accepted view. And I'll just add an interesting, I think, tidbit that I had been looking at the treatment of time for about 60 years. And I suddenly had it was a 60-year process of coming to this conclusion, but I had what is often called a eureka moment to conclude that time does not exist. There's something more fundamental underneath it. But until Jim talked, I hadn't even thought about quantization versus continuous. But since he brought up that new perspective, I realized that my replacement of time, and time is really just a more high-level generalization of what's really happening underneath, is quantized. So I'll just add that as another. I've come to the same conclusion about time and the more fundamental construct underneath time as being quantized from a totally different perspective. In fact, when I had my eureka moment, I didn't even realize that I'd gone from continuous to quantized. So that should endorse that concept, hopefully. I'll make one very small point. Jim, you put down the twin paradox as an example of a paradox that comes from not going to quantized, but I think that's just more of a problem of Einstein giving a special status to all inertial frames, whereas the true physics is the interaction between two physical entities. So that means that you can't just randomly or arbitrarily pick your base frame. The base frame is really one of the two interacting physical entities, like the gravitational field, motion with respect to the gravitational field. And you just can't pick another inertial frame arbitrarily. And GPS really shows that that's true to a high level of precision. That's my comments.
Thank you very much, Nick, for those interesting comments. And you've given reasons why. Denny, I have you there. Bring you later. I have some ideas there about, I suppose, basic concepts which have been in our philosophical psyche since Grecian times. We talk about the hare and the tortoise racing, where the tortoise has an advantage, an odd, and the hare can never catch up. And it depends whether we look at it in discrete or continuous fashion. And then, of course, the Newtonian calculus is basically looking at the limit of infinitely great number of infinitesimals, which effectively become continuous. But also this point, that Nick says, apart from the question of discreteness versus non-discreteness, the one of the paradoxes, which he's talked about in the twin paradox, is based maybe on something other or maybe more fundamental, giving equal status to all inertial frames and having this reciprocity. So before I bring Denny in, would have you any comment to make at all, Jim, on that, good, bad, or indifferent?
Yes, in connection with Nick's welcome comments, thank you, Nick. I view it that Nick is upholding one of the basics of scientific research, which is operational definition of concepts. In his presentations featuring movement of objects as an operational definition for the concept of time is a very welcome approach, I think. Now, if time is quantized, as Nick and Ian with the tortoise is suggesting or speculating about, then what about length and mass or energy in our basic definitions of the units of measurement in physics? So I'll ask that question. Now, I might add to this presentation a little bit of how binary mechanics started. It started with a rather arcane work by a man named James Hughes, who was at that time in pre-1980s time an MIT student, and then in all of the upheavals, social upheavals at that time, sort of dropped out. But he presented on a blackboard mounted in my kitchen. You can tell what sort of a guy I am to have a blackboard in my kitchen. At any rate, he presented how the Dirac spinors in a pair of relativistic Dirac equations of opposite-handedness, how that spinor matrix could be rotated to show that actually the spinors defined 8 points of a cube. So the 8 complex numbers in the normal wave function in the Dirac spinor pair that I mentioned actually quite possibly referred to events at 8 different spatial locations, the vertices of a cube, and then he went on to postulate, James Hughes did, a lattice of such cubes as the basic structure of space. In other words, James was referring to space having a structure, which I think relates to a lot of the work and speculation about the existence of an ether and so forth. Here, binary mechanics provides you with a very specific mathematical definition of the ether, if you will. Lastly, let me just mention the illusion of continuous space-time. If you look at my image on the screen or the image of the video that we just showed, it looks like everything is rather continuous, but it's all based upon digital processing, okay? So basically, we live in a binary universe, which the resolution is so great, as I've mentioned in previous discourses here in these sessions. I think, if I recall correctly, that the attosecond limit to what experimentalists have been able to define up to now actually consists of 350,000 ticks of the operation of the time development laws of binary mechanics as simulated in the simulator from Binary Mechanics Lab. So I'll just leave you with the idea that it is not a wild or strange idea that what appears to be quite continuous and real in a continuous space-time world can be, and in fact is generated, given current technology with 3D games and indeed This website that we're looking at right now, and my image right now, can be generated by entirely digitalized events in both space, time, and length. Well, the length goes with the space. So that's my comments for the moment.
So just before letting you go, Jim, and inviting Dr. Allen up, I just have a couple of comments from Cornelius, which may speak for themselves, or you may have something to add in response. He says, in binary mechanics, I think it is, where do constants L, M, and T come from, if not from deduction made from observation? And then he says, these constants are quantized only because we assigned C constant values to each quanta.
Well, if we look at the basic equations listed on the one slide that I showed, which showed all of the values in red boxes, it appears that there's only one possible set of M, L, and T values which satisfy all of those equations. So basically, it's a math question. I would ask professional mathematicians to consider the equations shown on that slide and set them up and attempt to determine if there is only one unique solution for the values of M, L, and T that satisfy all of those equations. Those equations are generally accepted in the physics world in terms of their dimensionality and so forth. For example, Planck's constant is energy times time in its units and so forth. So I would respond in that way, Ian.
Okay, Jim. Thank you very much. For the time being, there's only one more question. There may be more coming in, but perhaps if I could be forgiven for declining at present. He just says, MC, please tell us how things teleport. Well, I'd say there could be quite a number of possible explanations from that, depending upon whom you ask. And maybe it might not be totally germane to today's subject. So we may come back to that. But I'll bring Denny up now because he has a contribution to make. So Denny.
This is in regard to the idea that velocity has an upper limit. In a paper called Relativity in Classical Physics by Theodore Theodorson in the July-August 1995 issue of Galilean Electrodynamics. Who was Thorson, by the way? He was the head theorist at NACA, the forerunner of NASA, and it says here, in the heady days when astronauts evolved from a very primitive art into a full-fledged science, astronautics, excuse me. So he points out that there may not be an upper limit to C may not be an upper limit to velocity because it's just the upper limit to velocity where you accelerate things using electromagnetic fields. If you use, as Gottfried Guschke pointed out in his inertial propulsion mechanics, if you use his mechanics, you should be able to exceed the velocity of light by an arbitrary amount, depending on how well your equipment worked, of course. But this idea that the largest velocity is C is maybe faulty, and that by inertial propulsion devices, you may well be able to exceed that velocity.
Okay. Okay, thank you. Have you any comment to add to that observation?
Yes.
We have talked about some of those things before, of course.
First, a point in the slide showing the values in the red boxes used to derive the so-called fundamental constants, C and so forth. You note that bit velocity, the velocity that the maximum, well, that there are really two velocities. Zero, a one state low locus does not move to another location distance L away, or moves. And that distance, L divided by T, is defines a velocity called bit velocity. And that velocity is pi times the speed of light. So binary mechanics does say that bit velocity is actually pi times in other words, greater than pi times the speed of light. And so that's something to take into account. It also makes a prediction that nothing could move greater than pi times the speed of light. So there you have a concrete prediction. Excuse me. So that would be my response to Dennis's points, which are very welcome.
Well, that prediction, in other words, you're saying that that's your prediction, and if it can be shown that that's not true, then it would rule out your theory. Is that what you're saying?
Pretty much so, yes.
I see. Thank you.
So far, all the predictions of binary mechanics have worked out. For example, that the importance of surface temperature in gravitation effects, which have ruled out, if we want to use, as Dennis points out, the possibility of ruling out a theory, my work rules out general relativity of Einstein. Bingo, gone. Because the effects that I demonstrated by analyzing lunar laser ranging data and the twin Grace satellite data in both cases cannot be explained by general relativity.
No, general relativity doesn't explain temperature dependence of weight.
Of what? Temperature dependence of what?
Weight,
Dennis?
weight, W-I-G-H-T, weight.
Oh, yes. Okay, very good. Thank you, sir.
And it's interesting. What one might plead that a number of us have reached similar conclusions based on quite different data. You know, you've mentioned one or two there, and I've looked at the basis for things like the speed of light not being a speed limit, based on, you know, the energy content and the energy interaction of gravitational fields and electrostatic fields and so on. So somebody did say to me once that we might be cranks, but if we're all sort of coming to similar conclusions from different directions, that might indicate there could be at least something in what we're saying.
Yes, and my work shows also that in the unidirectional measurements of light speed that I presented here, in fact, and in my video, it's the next video down on the left of the BitChute thing. At any rate, that some of the bits are quanta arrive just before what would be the wave front of the main wave arriving, and this is faster than light transmission seen in those data. And I have a whole paper on faster than light transmission in terms of its mechanisms in binary mechanics and how it actually works.
Oh, okay, thank you, and thank you, Jim, and thank you, Denny. But by the way, just to dispose of one thing, Cornelius has been putting some comments in, and we've tried to capture one or two of them. But I don't know why you're having difficulty getting into the green room. I think you suggest you were. If you look at the third link on the announcement for today's meeting, http://live.naturalphilosophy.org. Well, that should get you directly in because the link has been updated. So you might wish to try that. And I've some slightly disappointing news as well, that Eric has had to leave. I think he's a bit maybe tired of some of the discussion, but so I don't think we'll be able to show the video, or unless somebody has the link. He's left. Now, what is that? At first, I thought. Let me see. At first, I thought that it was the material density decreasing with temperature that caused the speed of light to increase, but it does seem the medium itself can be heated up. There's another comment made about comparing times and mathematically. He says, Joseph, there is no twin paradox in current SR because times cannot be compared. Only invariance can be compared. This is the basis of mathematics. He who compares times is not a mathematician. Well, that's one of the explanations that's frequently given. Actually, there are about 20 explanations which are given as to why what appears to be a paradox isn't. Now, Nick wanted to come back because this actually is Nick's area, so I think he may want to comment on this. So please, Nick, what was your comment?
Yes, I've heard twin paradox is one of my specialties, and I've heard that a number of times. What that shows is not a defense of special relativity, but rather an indictment. Because what happens when you have an observer-centric theory, like special relativity, where every inertial frame observer's view is supposed to be equally valid, but all of these views contradict each other. And that's really best shown by the twin paradox and the example that was given in that quote by Ian. It shows that special relativity really sucks out all of the physics, because the only thing that special relativity can predict is what's the net proper time difference for the entire trip. It can't predict what's the cause or how the net proper time difference accumulates, because each inertial observer has a different view. But that doesn't mean that there's just indeterminate physics going on. It just means that special relativity, when it's relativistic and it accepts many contradictory views, that makes it impossible to tell what's going on. So if you go with special relativity, there's no way you can see what's actually physically happening, and it doesn't in any way resolve the twin paradox. And the twin paradox is again the problem that Dingle raised with the twin paradox is confirmed by GPS data, that the clock retardation is a function of absolute velocity rather than relative velocity. So that's Einstein got it wrong when he raised the twin paradox claim back in 1905, and Einstein himself admitted that in 1916 when he recanted that claim and said instead that the net proper time difference was caused by something else.
Sorry, I just cut you off there. You had finished, Nick, had you? Yeah. Okay. Yep. But presumably he didn't specify exactly what it was caused by. He didn't put it in the terms that you've put it there.
Well, he did say that it was caused by a virtual, the acceleration that was needed created a virtual gravitational field, which I think, just listening to that explanation, it seems rather dubious. But people like Max Born, who was an ardent relativist, bought into it. So it shows that some people with great analytical capabilities will suspend those great analytical capabilities to preserve a very strong belief system.
And that's why presumably some of the physicists have said, "Oh, you need general relativity to understand this properly."
Yeah. And let me make a comment about general relativity. Jim said that general relativity was wrong. I view general relativity as being in at least 2 and maybe 3 parts, and that is Einstein's original gravitational equations are part 1, and they're non-relativistic, but then a lot of to make the scope of general relativity cover more than just gravitation, a lot of special relativity and its problems were added to general relativity, and those additions definitely are flawed. In addition, Einstein brought in the equivalence principle, which Ron Hatch properly showed that there were major flaws in the equivalence principle. And Ron Hatch was, before his death, a great expert in general relativity data.
Right.
I think of general relativity as being in 3 parts, some of which have flaws, but other parts have different flaws, and one part doesn't have those same flaws. Just a point in passing.
Okay. And it's also been suggested sometimes that it's just an extrapolation of just surmises which were initiated by Bernard Riemann, just because of his non-Euclidean geometry, and maybe Einstein is just fiddling around and just trying to make that totally physical. Okay. What does MC say?
I have another quick comment that James might be interested in.
Go ahead.
And hopefully some in the audience. I noticed that quite often the equations for energy and for time were canonically the same. And that goes back to my thought that, time does not have a dimension. Everything unfolds within 3-dimensional space. And what's really happening is we see processes unfolding, and we have become used to thinking of this new construct of time, but really the most basic process is reality, physical reality, is physical processes unfolding. And the thing that drives processes is energy. So it's not surprising that time and energy would have the same canonical form, because it's really energy is driving that which we see, namely processes, which generates the construct of time. So for one thing, James talked about is energy quantized. That would say that both time and energy are quantized, and that's not a surprise because they're indirectly connected. Energy is driving the process, so the process that's driving the thing that's driving the process is quantized. It's not unexpected that the process itself is quantized, and that the thing that we observe and call time is also quantized. Thank you.
And I suppose it could be said that the entropic movement of energy dictates the arrow of time in one particular direction. This is another point. Yeah. Okay.
Yes.
Lovely. Good ideas. Great ideas. MC's come back. Discrete space and time also does not put it up. Well, we didn't say it did solve the photoelectric effect. Does not solve the photoelectric effect. Therefore, does not explain the Planck's constant. I suppose we're not saying it's a be all and end all. You need some other things. Okay. Cornelius coming. Yeah, and when I attempt to enter, it led me to a session and the screen was like, yeah, I don't know. We might have to do that offline to see how. Harvey's come in with a long session. Let's just see what he's saying. Energy precedes matter. Matter where the particle is the quantized or coherent energy left behind by the primordial energy. Gravity field is the destructive interference of the primordial energy. Electric fields where the particle is not. The primordial energy is the source for the still flowing power throughout the universe at near infinite velocity, tying the galactic web plasma circuits together and driving all motion. This is almost like, well, it might explain what's commonly, or it might connote what's commonly called action at a distance, because these things are all, you say infinite velocity. I talk about very, very, very rapid interactions, like gravitational interaction, but I don't talk about it as being infinite, which to me is a singularity. You actually said near infinite, so that's fine. Okay, fine. No major disagreement there. Now, but by the way, just one other person, Bob Gray is here in the green room. Anything to add at this stage, Bob, or would you like to leave it for the present? I see you're blank and your mic is in mute. But okay, if you don't want to come in at present, we'll proceed. Now, it's a pity about Eric because we wanted actually to look at his video, which presented some of the information in more detail than we were able to glean from his talk. I mean, he had the kitchen blackboard as well, which was great, but a bit hard to follow. So he has it all encapsulated into a short video, which he was going to show us now, but unfortunately he's disappeared. So we either have to retrieve that, or we have to maybe we have to go into Nick's site and perhaps have a look at something there, or maybe continue the discussion. I just Nick again. Is there anything specific on your site, any video that you think might be worth showing now? It might follow on some of the ideas which we've expressed today. You're mute. You're mute. Can't hear you. Can I unmute you? It's odd now. No, your mic is mute. It's odd now. I should be able to unmute you. We're not hearing you, Nick. I'm sorry about this. Can you unmute yourself? I know you're on a different computer from the one you normally use.
Okay, sorry.
Yeah, good.
Sorry about that. Yeah, do you have the list in front of you? I don't have that list.
I'd have to go into your website to do that.
Yeah,
I think
it's the YouTube channel. I think.
Yeah, your YouTube channel. But perhaps I should do that. I can I might have it as a bookmark, or I might have to ask you to remind me.
And by the way, we had an unusual circumstance. Abby's computer was down. We don't necessarily have to fill the entire 2 hours. I think the people who were patient were rewarded quite adequately by James's presentation.
Yes,
quite on a high after seeing that. Very, very exciting.
That is true. I suppose, in a way, I was also hoping, beyond hope, that if we stayed here until the end,
yeah.
Abby might have a chance of coming back. But I think it's very unlikely. In fact, I think he was trying to get in, but he seems to have disappeared now. So he yeah. Well, let me just see. Do I have your site? I can always search for it, but if I have it here, yeah, I have your site here. Now, it's the Nick of Time YouTube. That's what it is. Now, if I go into that, I think I deleted myself. I went into your thing and I deleted myself, so I had to rejoin. Anyway, so I should really maybe do what I did before, which means opening another window, perhaps. Maybe I'll try that. Let me see now. I had it here a second ago. Here it is. And I have to share screen. So let's see, can I do that? I have to present. And I said, share screen. Nick of Time. Share. Okay, so see, we have things. We have the various presentations which are interesting, but we have discussed them in recent times. Things like the inertial mechanics of Denny's, the Gucci's work, and Faraday experiments. We've really gone into great detail on the unipolar. Going back a while to energy transformation. Let me just see. Is there anything there, Nick, that you think might be interesting at this juncture? We're more than halfway through the session. You had that one on. I'll just try to bring it up now. It was
GPS clock rates.
Yes.
That might be of interest. I don't. You'll have to cut it short because I don't know how long it was, but certainly the whole thing goes maybe 2 hours.
There are two.
That's 23 minutes. That's not bad. Yeah.
It's only 23 minutes. Yeah.
Yeah.
GPS data on clock rate. Well, shall I put that up? And that might bring us to wrapping up. GPS data on clock rates and velocity is at odds with special relativity. Okay.
Yeah.
So perhaps I'll put that up.
Yeah.
And I'll try to make it full screen as well.
So here we get the insights of one of the key designers.
Hello, this is Nick of Time. Welcome to this 12th talk in this series about time.
Seem to have lost the.
What's happening again? So I just see you and me. Now I just see me.
I've just stopped it for a second. It's working on my screen, but I just want to make sure that everybody can see it. Could you see that a moment ago? The black slide with the sort of mauve writing in it. Could everybody see that? Nick, you said you could only see the two of us.
Yeah.
So you couldn't see your thing.
Start it again, and I'll let you know.
Okay.
Okay, I see it.
Okay. Well, if I leave the two of us up, we'll be in the left-hand corner. But just maybe in case there's a bug, you can let us know.
Okay.
Now, how do I restart it? It's gone a bit.
Take your cursor down.
Yeah, I seem to be doing that, but because this is where I brought it up.
Okay.
It's very odd now. It doesn't seem to be live.
Are we getting sound? I don't hear anything.
No, we're not. We're getting nothing at the moment. But I've brought it up a different way.
Can you start it down in the lower left?
No, that doesn't seem to work. See, if I maybe this is it.
The previous talks have shown that special relativity time dilation equation cannot describe proper time rates. Changes to proper time. Our conclusion of this talk, which I'll present up front, and then we'll go through the details of how we get to that conclusion. We're going to show that GPS data by the ton shows that atomic clock rates change as a function of velocity. Further, it's a function of absolute velocity rather than relative velocity. So we have two levels of incompatibility between the GPS data and special relativity. Hence, a new cause for this velocity effect on clocks must be found. Can't be explained in terms of special relativity constructs. We have to go and find the real cause. Let's do a quick review of the GPS system. It's used by most everybody worldwide. There were a set of GPS stations located various places on the surface of the Earth. However, people who are on the Earth will not have line of sight communication with those stations and hence can't really communicate with those stations. Therefore, to use it as a navigation system, people traveling on the Earth must really communicate with a satellite, which in turn communicates with the GPS stations on the surface of the Earth. So those GPS stations on the surface of the Earth, the clocks they use are synchronized using the Earth-centered, Earth-fixed frame, the EC-EF frame. Now the GPS clocks in the GPS satellites have to be synchronized with those earthbound clocks as well. Now, the GPS satellites are not geostationary. They do not hover over a specific spot on the Earth. They orbit the Earth. So, to synchronize those clocks, they have to take into account the velocity effects of those satellites relative to the velocity effects on the clocks on the surface of the Earth. Now, the clocks will all be set to universal time coordinated system. Just some general comments about the exposition. The GPS system is a real world system that works to high precision, and hence there are a lot of real world problems and real world complexities. We won't ignore those complexities when we do the analysis, but for this exposition, we'll try and keep things simple and not go into every single detail. For example, the GPS clock rates depend on velocity and on gravitational potential, where we're focusing on velocity effects on clock rates. So we'll focus on that, and we'll not talk about gravitational potential effects, at least not much. But that does not mean that we're leaving gravitational potential effects out of our analysis. That's part of our analysis, but we'll just focus on what the data is telling us about velocity effects. In addition, the GPS satellite clock rates are adjusted to equal the earthbound clock rate. So we won't mention that if we're talking about the satellite clock rates are slow with respect to the slowed by their velocity. That's already adjusted into the clock rate of the satellite system. So we're not ignoring that fact in our analysis, but we won't give the parenthetical clause each time we talk about satellite clock rates. Hence, as we say, to simplify the exposition, we'll just focus on what the data tells us about the velocity effects on clock rates. Okay, it's pretty simple. Satellite atomic clocks are adjusted to have the same rates as earthbound clocks. Again, the earthbound clocks have been synchronized in the ECEF frame. They're synchronized by accounting for velocity and gravitational potential. Again, we won't talk much about the gravitational potential. The fact is, those clock rates are adjusted by accounting for their velocity. That means GPS depends on adjusting the physical clock rate, the physical proper time accumulation rate of those clocks. And hence, GPS has a problem for special relativity time dilation, because in our previous talks, we showed we had 3 levels of problems. We showed that special relativity's time dilation can't be interpreted as describing proper time rates. You come to contradictions. And again, the problems are so deep that we can accept many erroneous relativist rebuttals and still come up with contradictions. 3 levels of contradictions. Some of those levels have multiple reasons why they're contradictory, why there's a big problem for special relativity. So we've come to the conclusion very quickly, very simply, that special relativity time dilation is not being used in GPS, because GPS is built on adjusting for physical changes in proper time accumulation rates based on velocity, as well as other effects.
Sure.
Very straightforward. No one can argue with that. And yet there's another problem. Even if the relativists insist that the time dilation equation can be used to describe proper time accumulation rates, there's still another level of problems. Let's look at that. Okay, the velocity of the earthbound and satellite clocks are used relative to the ECI frame, the Earth-centered inertial frame. You take the center of the Earth and you have a non-rotating frame. And then one uses a ratio of the velocities of the satellite GPS clocks versus the earthbound GPS clocks. And you calculate to determine the adjustment needed for the velocity effect. Thus, special relativity's relative velocity between the 2 sets of clocks is not used, but rather an absolute velocity with respect to a single frame is used. Thus, the special relativity model is not used, but instead, the Lorentz relativity model is used. Okay, we'll look at that a little deeper. Using a third party frame really is not part of the special relativity model for looking at clock rates. Remember, we're accepting the special relativist claim, saying that special relativity time dilation describes proper time rates and changes in proper time rates as a function of velocity. Now, here this little diagram below says we have C at rest in a specific frame. Let's call it the Earth-centered inertial frame. And A's clock is moving off to the left with velocity v with respect to C. And B's clock is moving off to the right at velocity v, the same velocity, but in the opposite direction, with respect to C. Now let's use special relativity's time dilation equation. Well, A would say, if we're interpreting time dilation as changing clock rate, A would say that B's clock is slower than his own clock, B's clock. Conversely, B would say that A's clock is slower than his own clock, B's clock. And someone in the third party frame would have a different view. In this case, C would see both A and B moving away with relative velocity v. So C would conclude that both A and B's clocks slow down relative to its own clock by the same amount, and therefore would conclude that A's clock and B's clock are running at the same rate. So that's the third conclusion, a third contradictory conclusion. And if you had another third-party frame, D, that would say moving at half V to the left, D would come to a fourth conclusion about the relative rates of A and B. So you can't choose, arbitrarily choose a third party frame to do calculations on the rate of A versus B. In fact, the only frame that you could choose that would be high precision and moves very close to that frame would be a frame that is the preferred frame in a Lorentz relativity system, where there physically was a preferred frame. And then the special relativity equation would work out because the relative velocity with respect to that preferred frame is also the actual absolute velocity. So if you've chosen a third-party frame and the system works to high precision, that shows that you're in a preferred frame system and that you've accurately located the preferred frame. In this case, at least in the vicinity of the Earth, the ECI frame would be the preferred frame or very, very close to the preferred frame. Your degree of precision and accuracy would say how close you are to having determined the actual preferred frame. So let's look at the special relativity model and GPS. By our previous talks, we know that special relativity time dilation does not describe proper time accumulation rates. So otherwise, there's an obvious contradiction. You determine that A's clock is slower than B's clock, and B's clock is slower than A's clock, and that's not just counterintuitive, that's counterlogical. So, in special relativity, one cannot, well, further, in special relativity, one cannot arbitrarily choose a third-party frame to determine the time dilation effect between clocks and two other frames. And you can't do that because one would get different contradictory results depending on which third-party frame was chosen. So, our conclusion. GPS is a widely used system that works to high precision based on the Lorentz relativity preferred frame model, with ECI, the ECI frame, as the single preferred frame. And the GPS data on proper time accumulation rates as a function of velocity is not consistent with the special relativity model. And this is very simple to see, and I'm sure that the relativists can come up with arguments, but to come up with reasonable arguments is very difficult. You can't argue that the clocks are adjusted, the proper time rates are adjusted, and right there that rules out special relativity's time dilation. Further, we conclude that GPS data is also not compatible with a just observed interpretation of special relativity time dilation. time dilation. Because just observed interpretation means that the observations would have to be symmetric, whereas in GPS, the observations, the communication between the two sets of clocks, is symmetric only because the clocks are manually adjusted to be different rates, which would show that the clocks are actually not symmetric. The non-adjusted clocks would not be symmetric. We have an asymmetric difference. That means there's a physical difference in the clock rates. GPS data is also not compatible with special relativities. All inertial frames are equal, because one would find that if you picked another frame other than the ECI frame, one that was significantly different, then the GPS system wouldn't work. You have, again, cars going into lakes or going into someone else's kitchen. So, special relativity's model of time is inconsistent with GPS's empirical data. Very important conclusion. This topic really gets me pumped up. It's very powerful. Okay, you might say, well, why should I listen to you? Nick of time, you're a nobody. Well, I might say, well, that's an excellent point. So let's call in a world-renowned expert on navigational systems, in particular the GPS system, which is a navigational system. Ron Hatch. He's a holder of over 30 patents for the GPS system. He knows the GPS system really well, and he knows the GPS data as well as anyone on the earth. And he also knows other systems like BBLI and the NASA navigation systems. He says, rather than supporting relativity theory, GPS actually reveals flaws in relativity theory along the lines that we've been talking about. He's reviewed what I say and concurs with what I have presented here. Okay, so what's next in our series of talks?
You want to stop it there? It's probably okay.
In part 2 here.
You want to stop it there?
Yeah, I think so.
The Havel-Keating and other things, maybe for another day. Let's see, can I get it back now? I have to stop sharing. Let me see now. Maybe that isn't right. Here we are. Yeah, I think I'm back, except I'm full screen. I just want to see the comments. Yeah, I hope everybody saw that. I was a little worried that it might be fine for me and others couldn't see it, but I think Nick would have shouted out.
Yeah, I could see it fine.
Everything's fine. Okay. So, I mean, for my own part, even though in 23 minutes, it was a very succinct summary of the essentials of this subject, which Nick has been at for 60 years. And I think it's presented them very, very well. So what? GPS does not work. I don't know what that comment is. But
GPS works very well.
Yeah, I don't know what this comment, I just put it. So what? GPS does not work? I don't know. I think he might have misunderstood it. I'm not quite sure.
Oh. GPS works really well, and it uses a model other than special relativity.
And the interesting thing is that not only do the conventional people say that is not contradictory to SRT, and they marshal these arguments. They said it actually proves the truth of SRT. They go further. They say, when you raise doubts about some of the predictions of SRT, they say, well, if SRT were wrong, GPS wouldn't work. They say the opposite.
And the explanation for that is that special relativity's results will work if your measurement uses the single preferred frame. So that's the one frame where special relativity and the Lorentz model have the same equation. So if you're not aware of Lorentz relativity theory, and that it's very different than special relativity, you may think you're using special relativity because you're using a special relativity equation, but instead of the V standing for relative velocity, you're actually using absolute velocity. So I can understand why people who don't have the whole picture and don't understand the difference between Lorentz relativity and special relativity might be deluded into thinking, hey, it's consistent with special relativity. You have to go deeper than just looking at the math equation. You have to understand the physical model behind that equation. And if special relativity were correct, then you could choose any inertial frame and do your velocity measurements and get the right answer. But it turns out there's one and only one frame that gives you the right answer.
I liked your introduction of the third party, the C, where he gives even another example. So that's something
I have a message on my borrowed computer. It's your battery is running low, so I may exit at any time.
Okay. You're not plugged in. Actually, I'm just getting some messages in the private chat now that would allow us to go on for hours had we the time, because Bob Gray, I think, has introduced a new number of videos on Kirchhoff's laws, and maybe they're not quite correct.
Yeah.
And I think Jim has given us a link to Eric Reiter's video, which we wanted to look at. So let me see now. I don't know how long Eric's talk is. We don't have very much long left if we want to discuss in a little more detail what we've considered already. By the way, just before asking you what you want to do, I just one observation, Nick. You're obviously using the ECI frame as the general frame out of the Earth, but on one occasion you said that earthbound clocks are synchronized in the ECEF frame instead of the ECI. I thought they would have allowed for any Sagnac correction on different parts of the Earth, which surely would mean that it's the ECI frame.
They are all synchronized together, but in GPS, the effect of their velocity with respect to the ECI frame is the key velocity in synchronizing it with the satellite clocks. So in EPS, to function properly, uses the absolute velocity, absolute rotational velocity of the clocks on the surface of the Earth.
Yeah, absolutely.
But they're synchronized so that they can have universal time, UTC, which is used on Earth. But to get it synchronized with to account for the velocity effects, they have to use absolute velocity with respect to the ECI frame.
Okay. Now, my suggestion would be, and let me know if there's any dissent, would be that it would be rather rushed to show another video, and Eric isn't here to answer any questions, so we might sort of postpone that to another occasion, because I'd like to thrash this out a little more. And I also see that Harry has joined, so Harry may have something on the subject because I know he's looked at it. So if that's agreeable, perhaps we'll spend the next 20 minutes max just addressing some of these questions. I also have a few questions here. Let me just look at them quickly before I ask Harry or Bob want to speak. Cornelius says, relativity does not disagree with GPS clock changes. It gives an explanation for them. In addition, general relativity gives an explanation for clock change due to gravity. Well, what's an explanation? I mean,
all I can say is that the world's experts disagree with world's experts on GPS disagree with you.
Yeah. Okay.
I mean, with the caveat that I just explained, that you're using an equation that looks like special relativity's equation, but the
he's gone. I think the power has gone. I think Nick gave us a warning. So unfortunately, we're going to improvise. I think, yeah, he's gone black. That's unfortunate. But I mean, it's been said to me at actually conventional. I was at an exhibition some years ago when we were talking about the Einstein eclipse and so on, and the lecturer said, "Oh, well, that proves special relativity and general relativity because you're using the same form of equations." So I just said, "No, it proves that atomic clocks change their rate of frequency under different conditions, different gravitational or relative velocity changes relative to the ECI." So that was the way I mentioned that. Let's see, one or two other things. You can do the same calculations for GPS corrections from the IS. Yeah, that's true. In spectral, there's no such thing as a preferred frame of major. Well, we know that. What is Cornelius is back again? He said, all this, as well as apparent quantization of action, is explained by the volumetric resonance frequency of space and time and the entrainment interactions between waves. These are just conceptions. Waves, no plus absolute. What's he say here now? Doc Mon, with a caveat that an expert on GPS doesn't think special relativity works with GPS, and that person isn't on this chat to defend that idea. Actually, I think Nick used the present tense maybe once or twice in just talking about Ron's ideas, which I suppose are in the present for all time. But actually, Ron Hatch, unfortunately, died some time ago. I don't know, about 18 months ago or something like that. So, and look, we would always indicate that, irrespective of whether you have academic credentials or credentials with regard to recognition, you're entitled to your view, but it's always nice to be able to quote somebody with 30 patents behind him in this very fundamental philosophy who does agree with the general ideas which were expressed by Nick. So we're not saying we're not saying that you need that, but it's quite nice when you do have it. Okay, so if I just so Ron Hatch, now let me see. Harry is there. Harry, if I bring you up, I wonder, have you any specific responses to any of the material we've been talking today, but particularly the material just recently, because it has brought on a lot of questions, which I've only tried to gloss over quickly. We don't really have the time to go through them all. But would you like to summarize?
I have a comment on James's presentation. I also have some comment on Nick's presentation. And what this discussion that we've had here shows a lot of confusion about different people's different perceptions about what science is and what physics is. And I was very confused by James's presentation, because he seems to be saying that as a physical reality, time and space are quantized. And then he talks about binary mechanics as a mathematical model. And so I'm completely confused as to whether he's saying, whether he's advocating mathematical model or whether it's advocating a physical reality, a description of physical reality in his binary mechanics. I'm completely confused by that. And that seems to be a big flaw in this discussions and these discussions that we're having, particularly when the business of special relativity came in. And I noticed there was a comment there where the guy said, well, you know, you're not comparing times. In other words, you know, the twin paradox, the times are not the same in the twin paradox. So that's just another paradigm. I mean, it's just confusing. And we're talking about different things. And why can't we talk about the same thing, which is, what are we really talking about? Are we talking about math models or are we talking about physical reality? And I see a lot of confusion between those two different things. You know, special relativity is a math model that attempts to describe physical reality. And so what Nick is saying is that the physical reality that is represented by a physical system that actually works called GPS, that doesn't really match up well with the mathematical model called special relativity. And then people want to say, oh, but special relativity is correct. You know, but that's just a math model. Maybe there's a mistake in the math model. Basically, I think there's a mistake in the math model. And there's a lot of people who agree with that assertion. So why are we defending a math model that's probably defective? Special relativity is a mathematical model that's supposed to be describing nature. And then when we find out it doesn't describe nature very well, as in GPS, then everybody says, oh, but special relativity must be correct. And they refuse to accept that their math model doesn't really reflect reality. I mean, to me, let's just not hold on to these physical illusions that we have that are math models and say, oh, the math model is correct, even though it's contradicted by physical reality and doesn't make sense when we apply this math model to physical reality. I mean, this is not really going to this isn't creating progress in scientific physics.
Those are very interesting points. I'm just wondering,
That's
Nick
my
has gone, unfortunately.
comment. To
You're
question
breaking up.
about what my
I'm just
question.
wondering if
question,
I'm going to bring James up. He might want to respond insofar as it relates to his presentation, Harry. Anything to address to Harry's general point?
Yes, I agree with Harry in terms of the idea of physical illusions. The belief that space and time are continuous variables appears to be a physical illusion. So I thank Harry for that. With regard to the equations which do reflect reality in terms of measured observations, such as the values of the so-called fundamental constants, binary mechanics does provide a mathematical framework which is consistent with the physical reality of what those measured values in fact are. That's it.
So
Thank you, Harry.
So you're saying that physical reality is quantized in both space and time because your math model claims it's so.
No, I'm saying that you've got 2/3 of it.
Well, but you have a math model that's making a claim that contradicts reality. Okay, you're saying your math model would put electrical engineering out of business. How does your math model explain the propagation of electromagnetic waves? How does your math model explain electricity and magnetism? I don't think it does. Your math model puts electrical engineering out of business as far as I could see. And so it can't be physical reality, but it might be a decent math model.
Well, for one thing, the classical equations used in electrical engineering at the macroscopic level seem to work quite fine, but they're only approximations of what occurs at the most microscopic level that binary mechanics deals with in its fundamental equations. Those equations do predict and are consistent with the actual measured values, so that the physical values that are actually measured for C, E, H, and other basic so-called universal constants are consistent with the mathematics of binary mechanics. So if you're looking for math that produces consistent results, binary mechanics is where you're going to find it at the macroscopic level. But I make no claims, and never have, that the classical equations at the macroscopic level are excellent representations of electromagnetic phenomena. And so you electrical engineers will continue to use those equations to
Well,
great
thanks a lot for
benefit.
that. I'm pleased to hear that.
Yeah, but if you're
I'm still in business.
yes, sir.
I also see that Nick is back. It's like a resurrection. So he must have got some power source there. And I'm just wondering if did you hear any of that? Harry was making a general statement, which I think applies to your presentation as much as Jim's. Did you hear that, Nick? No, you're mute again. You'll have to unmute yourself.
Unmute.
Hello.
Yeah, okay. Gotcha.
Yeah, what Harry said about special relativity, I think, is correct. It's a math model, but it's not consistent with physical reality, except if you happen to be use the single preferred frame. The GPS data can calculate what the relative velocity is between the satellite and the Earth, and that gives the wrong answer by a long shot. As I said, if they actually use special relativity and pick a frame other than the ECA frame, which they're supposed to be able to do, people would be driving into lakes and other people's kitchens because it's wrong, and we know it's wrong, and the data is clear. And the people who know the system best have gone on record on that, and it's pretty clear and pretty simple.
And as I say, it just seems such an anomaly that not only is there a slight disagreement as to whether this concurs with reality or not, but the main group say it proves that this is wrong, and most of us are saying no, it's contrary to that.
Yeah, but
universal.
That's because they're having the myopic view of.
Sorry, you've just gone again.
Oh, we lost him again.
Yeah, we lost him again. And just as he went, Harvey came in.
What I'm trying to say, Ian, if I might make a statement.
Go ahead, Harry. Go ahead.
The issue here, I think the issue here is that there is this confusion between what a math model, mathematics says, and what reality is. And physics is an attempt to essentially represent physical reality using mathematical models and other types of physical descriptions. And really what we want is we want those to match up. The problem is that people, this is I don't know if you're familiar with the U.S. Navy problem with torpedoes during World War II. The U.S. Navy torpedoes didn't work. And the commanders of the submarines and the ships kept reporting back that the torpedoes were defective. And the people who designed and built the torpedoes said, those people don't know what they're talking about. Our torpedoes work because we say they do. And it took it was a very difficult problem to resolve this. It had to go to the very highest levels of Navy or somebody said, hey, there's something wrong with the torpedoes and we need to fix it. And this is kind of a similar type thing that we have with this discussion of special relativity in science in general, and that is that the people who believe in theories because they've been taught these theories, and this is how physics has been taught and done for years and years and years, they don't want to acknowledge that there's a problem that needs to be fixed.
I think perhaps, if I may say so, that there is a problem in all of physics with regard to the interface between theory and experiment, mathematical models, if you like, and experiment. And sometimes it can be very unclear, on which side of this line one is. For example, it's sometimes said that the normal Gaussian theory of errors is believed by experimenters because they say, or they believe it has been established theoretically, and the theoreticians believe it because they believe that experimentally the results have been substantiated. So it hasn't been substantiated totally one way or the other.
Well, part of the problem is, the experiments could be misleading. Okay, that's a problem. And then the other side of the problem is the mathematics can be misleading.
Quite so.
Now, what I think is happening in the case of special relativity is, and relativity in general, is that the experiments are kind of confusing and misleading, and the mathematics is confusing and misleading. And so the explanations that try to bring the confusing experimental evidence and the confusing mathematics into some kind of consistent story, okay, that creates, a lot of confusion too. And Roger Anderton uses the metaphor of that they keep moving the goalposts, okay, which, I'm not sure they're moving the goalposts as much as they don't know where the goalposts ought to be. So, you have the argument between the experiment shows this and the mathematics says this, both of them may be wrong, which is what I think is the problem with relativity, and that people are misinterpreting some of the experiments and the mathematics is defective. But the experts don't want to believe that the mathematics has a problem in it. And so they want to impose a mathematics that's defective onto the experimental evidence. And so what we have is this case like GPS, where they don't really match up. That's the point that Nick has been trying to make, and people have been trying to make about GPS. And that is that the physical facts of the GPS system don't really match up perfectly with the theory of relativity as is claimed, but they come kind of close, so that people can claim, oh, this proves special relativity, or this proves relativity is correct. But on the other hand, there are some problems with that interpretation that don't really match up very well. And the issue is they have the torpedo designer's mentality, which is what we designed works perfectly and matches the theory perfectly, and we don't want to hear that there are any problems.
Well, I think this latter part of the discussion has been interesting, actually, and we could go on for long more, but we have to come to a conclusion now. And actually, Roger Anderton will be speaking in the coming weeks on this whole question of, changing goalposts and mistranslation and all that. And we can revert to this discussion, which I think Harry has raised these interesting points then. Also, we have some links given in the chat here to Eric Reiter's video, which we weren't able to look at today, and some other ones Bob Gray has given us from Sky Scholar. And we may be able to revert to those next time, actually, because as I said to you earlier, we have this gentleman, Jean de Clément, who has only referred to his videos. He the only reason he didn't want to speak in person is English isn't his first language, and he didn't feel comfortable with it. So, but he's given us a link to all his videos, so we'll be able to do that the next time. And so, unless Nick just come back has anything further to add, we might
before you sign off, Ian.
Yeah.
Before you sign off, is there a possibility that we can get this on a weekly schedule rather than a fortnight or a bi-weekly schedule? David doesn't seem to be producing any presentations, and I would like to see us on a weekly schedule if we could, rather than bi-weekly, because it confuses people and it doesn't create a continuity.
Yes, those are good points. Now, it appears that David at the moment is extremely busy. So, he may have something on next week, but on the other hand, we may not see him for some weeks. And that is problematic. And I do take your point. Now, unfortunately, from my own point, I'm able to do this every 2 weeks, but I wouldn't be able to do it every week. So if we could get another volunteer to do it, every second week, I'd be quite happy to hand over to him completely. I've done this for a while. Or I'd be happy to stay in and do it fortnightly with that help. So maybe offline, unless you have any specific suggestion now, Harry, if we could organize somebody who's willing to do that, maybe discuss the matter with David and just assure that indeed he is so busy that he won't be able to do anything in the coming months. Well, then we could organize something like that. I mean, for example, you might be happy to do it every second week, Harry. Maybe give that a bit of thought.
I could. I've been having problems with my computer working with StreamYard, but I think I found what the problem is, because it's working okay today. And that was one of the reasons why I wanted to get on here, to make sure, to see if I've solved that problem, because in the past, my computer just didn't work with StreamYard. So.
Well, that's fine. And your voice today is good. It was breaking up other days. But so if you'd like to engage in a little email, maybe with David included, we can work something like that out. And I'm very positive about that. The only personal problem is that I might not be able to attend very regularly those other weeks, because I've sort of devoted these fortnights. But we can discuss that offline. It's a good idea. So thanks very much for that.
I didn't realize your time.
Sorry, I've cut you off. Because I think it's Nick who wants to come back.
I was just saying, I didn't really appreciate that you had commitment issues. So
yeah,
okay.
Well, I don't want to give you a sob story, but actually, I said I wouldn't be able to do it at all because I was unclear about what's happening on Saturdays, and I was pushed a bit, in a positive way by people like Denny and so on. They'll try your best. So I managed to get every second Saturday free. It's just if I make a promise, I like to keep to us. We'll talk about that offline. I'm going to bring Nick back because he wants to add something. I think for the third time, yes. Nick, you got your power.
Yes, I emailed David, and he's agreeable to let us know if he's not going to have someone lined up, that he will tell us, but this will be on an ad hoc basis, and then we can. If we have somebody, we can fill in.
Well, that'd be great. So let's engage in some emails over the next week,
right?
About that. I was going to say one other thing which is important. Yes, the other thing is, I did realize I have a lot of help from all of you people, but I do realize that there is a sort of an onus on one to produce something. So I just warn Harry or anybody else who's willing to take this up that he'll have to go seeking talks. We can all help, but you do need a bit of encouragement. For example, today was unsuccessful, and in the next few minutes, I know we're a little over the time now, but I'll just summarize on what originally was meant to take place today and what we might do for the future. So thanks very much for Nick, and let's engage in discussions now over the next week or 10 days about that. Thank you. So in summarizing, I think we had actually a very good talk today, and it just shows that we do need to keep. I'm just looking at one other comment. Jim Morrison has asked, "Do you know Professor Howard Hayden?" Well, yeah, okay. We do know of him. It just shows that if we do come on more regularly, we have very interesting discussions. It gives us sort of some food for thought for the week. And for my part, I find it very stimulating. But today's talk was by Dr. Abhishek Chakravartty from Calcutta, and I've been in correspondence with him for some time, actually, back and forth about various ideas. And we thought we had everything sewn up for today, but unfortunately, the events proved otherwise, and it was just impossible to have him. And I don't think we'll be able to have him back in the short future if he manages to solve this very soon. Well, if we do have them every week, that might be possible to do that. But I have actually, luckily, sort of a schedule for the next number of weeks of various people coming in and so on. We'll announce that later. So keep an eye on the system. However, if Abby does wish to send me, for example, a paper, where he has the essentials of his ideas encapsulated, I'd be quite happy to present them to you. So that's an open offer. So I'd like to thank you all very much for participating, for your patience. We have announced something and we've improvised now, and we have something quite different. But I think it's been very, very, very interesting. Those two videos have occupied actually more than the 2 hours allotted to us, and a lot of interesting questions here. And thank you very much to everybody in the green room. You've all been most helpful. I'm sorry Eric did leave early. I'm sorry about that, but we'll get back. We might even show one of his videos next time. I'll leave you with that, and we must get into this conversation. And by the way, if any of you at all, any of you going through the system through Facebook or YouTube, if any of you has any ideas with regard to the desirability of holding this every week, or maybe you don't want that, you have enough, you think every 2 weeks is sufficient, just drop us a line. But the few of us in the organizational aspect through the green room will be discussing this over the next week or so. And it looks like we'll probably be taking up Harry's idea to do this more frequently. And the only thing is you'll have a break from me at least every other week. So thank you once again for all your contributions. A lot of food for thought there. And we look forward to meeting you again in the not too distant future. So I'll bid you goodbye and thank you again.